Good morning, students. This is our lesson on patterns in algebra, lesson 20, and that's found on page 85 through 87. It's called graphing sequences. Our last class, we talked about we talked about ordered pairs and sequences that turn into lower ordered pairs. Sequences can turn into ordered pairs very easily. Sequences are just series of numbers, and you turn it into an ordered pair by going through these two steps. If you are confident with your two steps, you can actually just do one step instead. And so we have the numbers 4, 7, 10, 13. That's our sequence. And then what we can say is every term, we can order them by using terms. So the very first term here is term number 1 is the number 4, term number 2 is number 7, term number 3 is the number 10, and then term number 4 is 13. So this is my original sequence. I've now put it onto a t-table, and then I can actually turn that into an ordered pair by having them written down like this. So term 1, or 1, 4, 2, 7, 3, 10, 4, 13. Now the nice thing about ordered pairs is these are very easily graphed now. Now when we do a graph, remember, we always do the horizontal first, which is the x value, which is this one right here. And then we do the y value after, which is the 4. Okay, so x is always across. We do that number first, and then we do the vertical number, which is the y. All right, so let's turn our page over and see what it looks like. So our numbers were as follows. 1, 4, 2, 7, 3, 10, 4, 13. Let's see what that looks like on my graph. So here I have a graph. I've skipped 2's going down. This is my horizontal, or this is my vertical side. This is my y-axis. This is my x-axis. I could even list that down. X-axis, y-axis, and then what I've done is I found each location. So my very first term was the value of 4. So 1, 4. Let's put it down. 1, 4. And the second value was 2, 7. 2, 7. This third term, 1, 3. This third term was 10, so 3, 10. And my last term was 4, 13. Now, this is actually an example of a linear sequence. So what is a linear sequence exactly? So a sequence is the 4, 7, 10, 13. Now it's a linear sequence because the gaps in between each number are consistent and make a perfectly straight line on a graph. Now we can have positive linear sequences like this one is, because it's going up the entire time. 4, 7, 10, 13, those are all going up. We can also have negative linear sequences, and that would actually make the line to go down. All right. So why do we know it's linear? Well, we can actually just show it by doing this sort of work. So here I have a sequence 3, 6, 9, 12, and because every single gap between each next term is consistently the same size, that would make it a linear sequence. And because it's a positive linear sequence because every single time you're adding a number in between. Okay, so this makes a positive linear sequence. This example right here, this is a sequence, but it's neither positive nor linear nor negative because it has a whole bunch of different jumps. So this one's +1, subtract 2, +8, +1, subtract 4. This is not consistent. It is still a sequence. We wouldn't say it's not a sequence because it's a series of numbers written in a row, but it's not linear, and it's also not positive or negative because it has both of them. Now this one is a linear sequence because it's consistently -2. It's also a negative linear sequence because it's going down every single time. Now, on a graph, these are going to look different from each other. This one, if we were to do this on a graph, it's a simple drawing. I'm going to do a little tiny graph like this. That's my graph. This one would probably look something like that. It's going constantly upwards, right? Because I'm increasing the number every single time. So my next number is always going to be higher than the last number. So it's going to cause a positive. It may not look exactly like this. It may be on more of a gentle line, depending on how I made my graph numbers, my scale. This one will look kind of odd, right? It would go bloop, 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 bloop. It'll go all over the place. It's not really consistent. That's not linear. It's not one straight line. Now this one is going to be constantly negative. So it'd be probably going down like that. So this is a positive linear sequence right here. This is a negative linear sequence, and this is just not a linear sequence at all. It's just a sequence. Now, I was thinking about what questions should we do with this information, and I wrote down a whole bunch of things and then realized that that's pretty much just all of them. So I'm going to have you do the all. Now this afternoon, I am going to be having a little math session. I'm going to be open up for an hour where if you have any questions or if you want to take up your work, you can come and see me. I'll have my teams open. And yeah, you're more than welcome to come by and check your work. You don't have to be there for the full hour. You could pop in for 10 minutes and leave after 10 minutes, whatever your preference is. All right. So I'd like you to do all, and that's page 85 through 87. And this is all about graphing sequences. All right. So I hope this was helpful, and I will hopefully see some of you at lunch.